Hello everybody. Today we are going to go through some vision picture records of mode 1907 recorded at station 24 on September the 30th and October the 1st. Let's start with picture number 1. In order to analyze picture number 1, let's check out this force on option for inspection number 1. We see that histogram average and contrast are out of order. Let's put the cursor on the histogram inspection. We can now see the histogram inspection region highlighted in red. So why it is out of order? If we look into the master file, we can find the histogram inspection region is defined here. It is in an area which is almost perfectly white. And the rib edge is far away from the inspection region in the master. If we look at the current picture, then we can find that the rib edge is cutting into the inspection region, and that is why the histogram average is lower and the contrast is high. In order to improve the situation, one thing we can do is to quickly change the histogram average control tolerance. If we lower down the minimum from 220 to 200, then the average is in spec. If we increase the contrast control from 60 to 80, 80 is still insufficient, to 85, then the contrast is in spec. However, since we found the root cause, the reason of out of spec is that the rib is coming into the inspection region. Why the rib comes into the inspection region? This is because the part is becoming smaller in the picture. The reason was because the part is too close to the lens. So the most appropriate way to correct this issue is to increase the robot kick so that the camera picture position is closer to the lens. In that way, the rib will be further from the inspection region. So you may have a question why, if we make the picture larger and then the rib can be far away from the region. To find the answer, we can look into the master file, and we can see there is a locating procedure defined here. So in the locating method, the first search will find a point on this rib, and the second search will find a point at the end of this rib, and finally, and also the most critical one is a point on this rib. So this point serves as the origin of a coordinate system, or we call that a fixture, in which the inspection regions are located. So the distance from this inspection region to this reference or this fixture origin point is constant. It's not changed. But this rib edge can appear closer to this point, to the origin, if the feature appears smaller in the camera picture. So the way we can improve the situation is that to make the feature closer to the camera lens. Okay. The reason that the feature becomes smaller is just because the variation from the end of arm tooling. Now let's take a look at the second picture. Okay, in the second picture, everything seems to be out. If you see everything is out, especially when the pattern score is 0, it means it didn't find a pattern. So what we need to check is the pattern search region first, to make sure the search region covers the feature. And now we take a look again. Everything is good now because the feature is within the search region, and the pattern is found, and then everything is good. Now let's take a look at the third picture. We can find that the black blob count, the black blob pixel count, is out of spec. It found zero. It found a 0 pixel of black blob. Let's take a look at the master. So for this region, blob region, it need to find certain number of black blob pixels, because this is a region with some short condition normally, and this short is not allowed to be too much. Therefore, we control the short condition by measuring the number of black blob pixels. Now in this picture, we can find that everything is almost white. Everything is almost white. We can still see some shadow of black, some shadow caused by the rib. However, it is not black. It is sufficiently black. The gray level is not sufficiently low to let it detect it. Well, if the program allows to adjust the black blob threshold, we can adjust that to be higher, and then we may be able to detect those black blobs. However, the control range is should be below 128 for that threshold. So we are not able to adjust that threshold any more higher. So the way we can make things to work will be reducing the camera exposure for this picture. For instance, reduce that to 17, and we can wait and see the picture effect of the next camera shot. Okay. Now let's take a look at the final picture. This is for inspection number 2. And therefore, let's uncheck force down for option for inspection 1, and let's check the force down for inspection number 2. So we are observing that the number of black blob pixel count is out of spec, and the number of black blob found is out of spec as well. So let's take a look at the master to see what is the requirement. So here is the black blob region. So the green highlighted in green is the region, is the black blob region found. So ideally, it should find one single black blob with sufficient number of black blob pixels. Let's take a look again in the vision in our inspection here. So we can find that there are two black blobs found. One is up here and the other is low here, and it's divided from almost the middle. Okay. Now, if we look into the program, here's the black blob inspection, and here's the threshold control. Can we change the threshold? Yes. If we increase the threshold a little bit, just by 1 point here, it already make difference. Of course, in reality, we can increase a little bit more to avoid further rejection in the future. And then let's take a look. Everything is good here. Okay, so that's all for all the 4 pictures. Thank you very much.